Greetings once again. My name is John Gabriel and this is a new calculus channel. And today I'm going to elaborate a little further on my previous video where I explained to you that the mainstream definition of derivative is nothing but laughable. So let's begin. So if you recall, I showed you that my historic geometric theorem exposes mainstream calculus, both the definite integral and the derivative, for the fraudulent formulation that it is. And it also contradicts their very own theory because, the limit of a constant is the constant itself. So you can't have, for example, the limit of a constant being something else, right? As you saw in the previous video, they take the limit of this non-parallel secant line, this red non-parallel secant line here, and they just turn it into the same slope as a derivative. Okay. Now, mainstream academics are ignorant morons, and they love to obfuscate things. So let's look at their so-called definition in terms of their epsilonics, their epsilon deltas, and see what it really reduces down to, which is really obvious, unremarkable, and, to be quite frank, just a load of bullshit and a load of hand-waving because it doesn't really explain anything. So this is their definition here that you see in the second line. And of course, note that L happens to be the derivative itself. So let's not bother about the circular concept right now, which it is circular, and just let's see what actually happens here. So we know that we can replace this epsilon here with the difference, which is the function q of xh, and just add any epsilon we like, right? So it doesn't matter. Obviously we can make epsilon as small as we like, any epsilon greater than 0, by simply letting this side of the inequality be equal to the difference plus some epsilon, right? And of course delta we can just let it be the same as h, which is really just the difference between these 2 points, right? So delta can be also anything we like, and that's all that the orangutans of mainstream academia are telling you. So if this just decreases, like this, all we can do is just say that this here, this absolute value is less than the difference. And of course it's going to be less than the difference as long as h is greater than 0. Of course, if h is 0, you've got this problem of an undefined finite difference, right, as you see over here. So what I'll do is I'm not going to carry on this video. I'll place a video in the details section and let you look at it yourself. And remember, you can place any function you like inside here and it'll work the same. So if you're not already a subscriber, become a subscriber. I do know better than anybody else, by the way. That's not arrogance, it's just a fact. So study what I'm telling you, because you'll be astounded and you'll actually understand calculus for the first time in your life. I've never met a mainstream professor of mathematics who actually understood calculus, even though supposedly they teach it. I consider them to be all incorrigibly stupid. Please feel free to donate credits or dollars on my Odyssey channel and tell your friends about my channel, and hopefully I'll be chatting with you again about some other interesting topic in the not too distant future. My name is John Gabriel and this is a new calculus channel. Till next time, goodbye.